So this is Poncelet n equals 4, so P1, P2, P3, P4, between two identical unit circles. So here's the incident circle on the left. I start with an incident point P1, then I draw the two tangents to the other unit circle on the right. So this first tangent here produces an intersection P2, and the second tangent produces this intersection P4. Then I repeat the Poncelet iteration. What do I mean by that? I compute the two tangents from P4. You're going to see that one of the tangents is repeated, the one through P1, and the second tangent, the second circle, produces this intersection P3, and then I iterate from P3, which I could have already done, right? Because I could have located P3, let's put it this way, through that first tangent, through P1, that gave me P2, so here are the two tangents, the second circle through P2, so there's one going through P1, already used, and then an unused one, this other tangent here, going through P3. And this is a closed trajectory because the distance between these two unit circles has been picked to the value of square root of 2 plus square root of 5, computed by Professor Ronaldo Garcia. So provided these two circles are centered at points O, O prime, which are distant from one another by this amount, we close Poncelet n equals 4, right? So this is a really interesting setup. You can see that the area of the quadrilateral drops to 0 for certain choices of P1, sliding P1 on the first circle. Now here I have represented two phenomena that are quite interesting. First of all, you can see here that there's a complete quadrangle formed here by the lines P1, P2, P2, P3, P4, P3, and P1, P4. So you have a collection of 4 lines, and these form a complete quadrangle in space. And complete quadrangle, you can look at its entry on Math World. It has many properties that were discovered in classical times. One of the interesting properties is that the midpoints M13, M24, and MQQ prime, I call these two intersections here QQ prime. By the way, let me actually cover this first phenomenon before I speak of the complete quadrangle. The locus of QQ prime, points QQ prime, appears to be a straight line, straight segment, right? So Q is moving along that first top segment there, the thick red one there, solid red, that seems to have endpoints at the intersection of this line with this right circle, tangent circle. And the top of this segment seems to be at the height of both circles here, right? So there would be a common tangent here, parallel to O prime, seems to be at the top end of this segment here. And then the same thing is happening down below. Let's animate this. You can see that Q and Q prime move along straight lines, a common straight line, right? Each one of them moves along a particular segment. Now the other phenomenon that I wanted to illustrate here has to do with this complete quadrangle, the midpoints M13, M24, and MQQ prime of the segments P1, P3, so you've got M13, then P2, P4, you've got M24, and then these bottom intersections, which are labeled as QQ prime, is also midpoint here. Now, it's known that these 3 points are collinear. What seems to be happening here, and that's a very interesting phenomenon, is that this line also passes through O prime, the center of the right circle. There you have it.